Mathematicians do not seem to be the most ordinary people who have ever roamed the face of the planet, but without them, we would not have answered the questions like, how do you find the circumference of a circle which led to the discovery of pi? Or what is the relationship of the sides of a right triangle leading to the Pythagorean theorem? Like many mathematicians before him, David Hilbert started off by answering problems. However, later, he decided that creating unsolvable problems sounded like a heck of a lot more fun. Seeing as he ended up creating 23 so-called unsolvable problems, I began to wonder if that is just what these mathematicians did to pass the time, like how some people play card games. This math game begins after Hilbert has spent many years going nowhere. He dislikes lecturing, and he finds it unfulfilling and not particularly predictable on the money side of things.
For our first problem, I suggest we classify second-degree line complexes using Weierstrass's theory of elementary divisors.
Felix, we all know that you've already figured that one out. What was it, almost 20 years ago? I, however, have a new problem. I challenge you all to figure out this problem. It is a mathematical problem on the rules of finite basis.
Challenge accepted, my friend. I will look into it despite my position at Göttingen University.
I will also look into it if you don't mind.
Go ahead, son.
If Hilbert could just solve this problem, maybe he could move on with his life, get away from lecturing, and move on to research.
I've got the answer.
No, you haven't.
Fool, Paul! You haven't even read it!
As it turned out, this was just the beginning of Hilbert's greatness. In 1892, Felix Klein asked Hilbert to move to Göttingen and resume his education. Hilbert, with his new wife, moved to Göttingen. The next year, his son Franz was born. From there, Hilbert's life continued to get better. After his education, he worked at a couple universities. Usually he was a professor's assistant or a researcher. He published a nice paper on the closest proof of the transcendence of pi and e. A reader of his works even called this work a veritable jewel of mathematical literature. Later on, Felix Klein invited Hilbert to come back to Göttingen University as a full-time professor. Hilbert was asked to retire from his position at the university many years later in the 1930s due to the fact that the Chancellor, Adolf Hitler, had placed restrictions on Jews that did not allow them to teach. He died 13 years later due to illness and depression. Alright, returning to the idea of math as a game, it seems that Mr. David Hilbert won. He came up with 23 so-called unsolvable problems. I say so-called because since Hilbert came up with them, a couple have been solved. Math and technology are ever-changing, so the fact that they have been solved takes nothing away from the great mathematician Hilbert was. The 23 problems are complex, and someone of my level of math could not possibly understand some of the questions well enough to explain them all to you in this video. Instead, I will talk about the problems that have been solved. Taking time and complexity into consideration, I will only discuss the original question and who solved it. Number 4. Find geometries whose axioms are closest to those of Euclidean geometry if the ordering and incoincidence axioms are retained, the congruence axioms weakened, and the equivalent of the parallel postulate omitted. This problem was solved by George Hamel, a colleague of Hilbert at the university. The 5th question has also been solved. Can the assumption of differentiability for functions defining a continuous transformation group be avoided? This was solved by John von Neumann, a Hungarian-American mathematician and physicist, and well, he was just a really smart dude. He solved the problem in 1930 for bicompact groups. Other mathematicians, Montgomery and Zippin and Andrew Gleason, agreed with von Neumann. Almost 100 years later, and these are the only 2 problems that have completely been solved. Some mathematicians have solved bits and pieces of the other questions, whereas some questions continue to stump mathematicians completely. It's obvious that Hilbert was one of the great minds of the 20th century, as his problems continue to stump mathematicians today and into the future.